Welcome to SkyTour Livestream. It is the 28th of January 2023, and we have a sky pregnant with Comet. Isn't that great? This is very cool. This beautiful tail, we'll talk all about that. This red is actually the edge of the building. We have a red LED on the end of the camera, and it shows on the building, and we see it in the camera. That's how we know there's an obstruction. And so it's actually pretty neat. We're going to clear and get the next image in here and see where we're going. So the comet is actually looking really good. There you can see we have this beautiful tail on it now. That long tail, that's the ion tail. And the ion tail is created when solar wind, as in protons and electrons from the sun, strike the comet, cause this greenish glow, which is diatomic carbon, which is two carbon atoms as a molecule, and a carbon atom mixed with a nitrogen atom to make cyanogen. And those two, when they're ionized, they glow green at that time, and so we see a greenish glow around many comets. This one is known as the green comet. And the upshot of that process is that ions go streaming away from the sun in the opposite direction of the sun. All right, and that's the opposite direction of the sun. Now, if you look carefully, you can see that the tail has this straight, tiny. It looks like it's very, very compact tail. All right, but if you look carefully, you see there are some undulations in the tail. There's some more detail. It's pretty cool, you know. And I do want to acknowledge that Tara is with us tonight. Tara Daulis, who is part of the SkyTour live stream organization. She has joined us tonight. Thank you for coming here, Tara, and coming out. And I do have to say, PG was the first one here tonight. Petita in Pennsylvania. Nice to see you. And we have Cyclone with us, Donald Kunzer. And we have ERRT Radio. Gee, that must be Ronald. Hi, Ronald. David Schmidt is here from Bangkok. Good to see you. Bonnie from Colorado on a HANA 77. Very cool to see you as well. Fantasy is here. Nice to see you. This Daryl guy is with us, but you know what? We can't get rid of him. That's great. Mike, I knew you were going to say that. And Michael Hedrick is here with us. How you doing, Mike? Good to have you. And Judy M. Hi, Judy. And look at that. Just that tail is just developing beautifully. Mary Kaczynski, how are you? Yeah, clear Arizona skies. And it's snowing for you in Wisconsin. Man, oh man, I'm sorry to hear that. Now, again, the comet will be more and more revealed as this red edge of the building, which you can see right over my head. You can see the telescope is actually kind of trying to peek over the edge of the building, and we're getting some of it. We're getting some of the edge of the wall right now. And Robin Curtis is here. Daisy and Zoe. Bullwinkle's with us. Fantastic. And I just think that it's wonderful you guys came out again to see this. Sam S. is with us. Kathy Pernisic, how are you? Yeah, and I'm telling you, we are just going to town here. And then Dave Schmidt says, Mark, before I forget, a few weeks ago, some chatters were discussing NASA's plans to colonize Mars, and I said, focus on the moon. I was saying NASA should focus on the moon first. Well, you know what? That's actually a very prescient thing to say. But if we can get to the moon, that's one thing. Getting to Mars is a whole different story. It's a lot harder. So we should perfect going to the moon first, and I have said that often. So I think Mars represents a giant leap, and I'm not sure that we're ready to make that leap yet. And I think you feel the same way. Yeah, I think I'll wait for the fusion reactor. Wow. And Kathy Pernisic says, Mark, great night for the Comet. Yes, indeed. Yes, indeed. Now, the Comet is moving very rapidly. So if we go and get out of this right here, I haven't saved any of these yet. And we will. We'll start saving them once we start clearing the building a little better. But if we go back to our 1 second night vision mode, and let's do some little tests, and I'll show you. Oh, I gotta get rid of this stack first. Okay, there we go. And now we do this night vision mode. Right, now let's go in here. This is actually going to be helpful because we're going to come in, and you see there's a little star right near the nucleus. See that? And we are at right here 75% of our sensor right now. Actually now up to 86. Let's do a little something. All right, let's draw a line, and see the star here? We're going to use that star. We're going to draw a line, all right, right over to here. All right, so when the line shows up, that line will be used as a measuring tool to watch the comet move up past it. And there it is. So now you'll see the star is going to stay locked where it is, but the comet is going to very quickly go up and go through that line, right? And this is because the comet is moving very, very fast. The closer it gets to us, the faster its apparent speed in the sky. So that's right. That's going to be beautiful. Oh, Lane is here with Daisy and Zoe. Hello, Lane. What do you think of the comet? Isn't it cool? Cindy Murphy, how are you? The transient facility. It's on the screen. They see it. You know. I'm sorry, but you're right. Yeah. You notice the star is at the end of this line right here, and the comet's getting closer and closer to that star. So this is interesting. You know, we're watching how the comet's changing its trajectory overnight tonight, and when we saw the tail, we saw it sticking out in a certain direction at a certain angle. That angle has changed since the other night, and we will see that when we go back to the other images. But notice the comet is now almost halfway across our line and almost to the end of our line. Right? So that's interesting. The comet, appears to be moving in that direction right there. So that's interesting how that's coming to be. And it's still approaching us. It'll be at closest approach in a few days. I think February 1st into February 2nd. It'll be at closest approach to us. And we will see it if we can stream. I mean, right now, they're projecting a rain out there for tomorrow and the night after. But after that, it'll be clear. And that will take us to a string of clarity in which we can watch the comet moving across the sky and pass in front of the Hyades cluster, possibly even. That'll be pretty. Yeah. So now the comet is halfway across our line and near the end of the line now. Look at that. It's actually occulting a star almost. I think it might actually be doing that. Let's see if we can zoom in on that. You mean the Earth's movement through space? Well, we're rotating out from under the stars, but we're following those stars. So the comet is actually the motions out there are actually rather complex. Okay, I mean the comet has its own trajectory, its own path. The Earth has its own path. The Earth is an elliptical path around the sun, almost a circle. The comet is a much more elliptical path, so it will be getting closer to us and farther from us. And right now, it's coming in over the top and heading for us, and we can figure that out. I did want to take a moment to show you some of the things that are coming for us down the line here, and I will pass these along as well. Let me first bring up our while we're waiting for the comet to a little longer. Let's do this. Okay, this is our left screen. I want to show you. Okay, right now out there, this is what we're looking at. I'm going to get rid of this name for now. Come here, you, right out of there. There we go. And we see Ursa Minor here, right there. This is Kochab. The comet was right here last night, and now it's way up here. So there's Polaris, the North Star. That's why our telescope is pointing way toward the back, almost along its axis, because it's pointing very close to the pole, relatively. So here is the comet right here. If we zoom in, you'll see that the comet, well, this will actually move. You'll see this moving through the sky. All right, that's right, right here. This is that star. And as you see, the comet's actually physically moving right in front of us here through the sky. See that? And it's being tracked by this application. This is Stellarium for the web, so you could do this too if you wanted to. Thanks, C&D boy. I'm glad that you learned a whole lot, and it's actually fun to hang out, isn't it? So the comet's heading this way, and it's going to actually end up being up here in short order. It's actually going to it'll be making a curve in its orbit relative to what we see, and we'll see that. There's no projected path here, though. I can show you. Yeah, I'll be up here. That's right here. Yeah, and we want to look at that. Well, there you go, the giraffe, Camelopardalis. And then a little later on, it's going to end up all the way up here by Mars, and it's actually gonna go right through this cluster and pass right in front of this cluster called the Hyades. And you can betcha we're gonna be watching that too. It's gonna be really pretty to see that. Yeah. Ooh, we're in the southern U.S. with this telescope. And we should look for it. If we can see the moon, we can see it. If it's going to occult Mars, we'll see it. We can only see part of it. Oh, shit. Okay, try now.
Testing, 1, 2, 3. Can you hear me?
Yeah, okay. I don't know why you weren't going out, but you weren't going out. I'm sorry about that. Just repeat that last segment about the occultation.
Yes. Where we missed the first part of the occultation in December, this time we will see both the disappearance and the reappearance of Mars on the 30th, weather permitting, of course.
We should have good weather.
What?
We should have good weather. I want to say hi to Marianne Robb, who's here. Marianne's the other part of SkyTour Livestream with us, along with Tara Diulis. And we're gonna have a great deal of fun in the coming months with SkyTour Livestream. We've got products to offer you. And don't ask for pricing or anything yet. We just have mock-ups, and things may change. But while we're waiting, I can give you just a little peek just to show you. Let's go back to this first and check out our Comet. You notice it's a 1 second exposure, so you're seeing it change. And there it is. Let's first go in now. Let's go in and do another 45-second exposure, and this one we're going to save. Okay, so we're going to actually call this Comet. I'm going to try and call it. There we are. Just a minute. Okay, Comet 2022. 22 is when it was found. E3
ZTF.
Zwicky Transient Facility, Palomar Mountain in California. That's where that's located. Okay, so there we go. So there it is. And now we'll do a 45-second shot to capture the comet. See how much of the comet we can see above the building. And we can see quite a bit, actually, but I want to do it again. All right, we'll go into our live stack now. There's the comet. Oh, it looks really pretty. Okay, so this is an overblown image that has to be cleared. All right, but that's what the comet's looking like. And there's the tail, and notice it's going down and to the right. And down and to the right for us means that the comet's actually... well, you'll see on the sensor. It'll give you an idea on the sensor. When we look at the sensor, the tail's direction will make sense in the in this imagery. Because right now it doesn't look correct, but 1 second from now you'll see. And there it is. Okay, so here is our comet, and we'll back out a little bit. Oh, that's gorgeous. Let's see if we can color correct a little bit here. Yeah, look at that tail. That tail's beautiful. Okay, I'm going to save this because this will be the cleanest shot, the 45-second shot. Alright, and we'll save exactly as seen. Alright, and then the second 45-second shot will start to clean up the noise. But for an official image, this will be good. Hey there, Robert Waters. How you doing?
I see black specks on my screen.
Yeah, I see them too. I'm not sure what those are.
I tried to clean my screen and it didn't go away.
Yeah, no, this is that's something else.
You been eating popcorn in front of the computer again?
No. Well, they weren't there yesterday, so the fact that they're there today shows that it's probably just a electrical, dead pixel location or something. We can, and they vary from time to time on the camera. We'll fix it.
Ronald, if you were flying in the tail of the comet, you probably wouldn't even know it.
Hey, you'd never see it. You might register that you're getting some radiation in the way of some ions, but you might not notice it because that tail is many thousands and thousands of miles across. Because it's so far away from us, it looks rather bright and obvious, but it'll be like going through the thinnest of thinnest Earth clouds, and then it would be probably, I'd say, about 30,000 or 40,000 times less dense than an Earth cloud. So there's a lot to consider with a comet. Here's another example. when the Cassini orbiter was done, or before it was done, they sent the Cassini orbiter through the rings of Saturn. They say, whoa, well, that's going to destroy it. It's going to collide with an ice particle. If it hit the tiniest of ice particles, it would have been destroyed at the speed it was moving. But it made it through without any problem. And that's because they said, well, statistics is on our side. The icy rings of Saturn are a few miles thick, and they're actually, the particles are separated by enough distance so that you would fly through it and not even know they were there if you were there. And so Cassini flew through unimpeded without any damage.
On the other hand, if you were flying close to the nucleus, or maybe trying to land on it, you may remember, what was the mission? Rosetta?
Yeah, that was Rosetta and the Philae lander.
When the Philae lander landed crooked on the Comet, it looked like a snowstorm was going on.
Yeah, very low gravity.
Stuff flying everywhere.
Yeah, very, very low gravity. Okay, we'll save this 3-minute and 45-second shot. Okay. And then we'll clear and do it again. Just in time. Look at that. There's the new shot. And we'll save that.
You sure you're not eating popcorn?
No, I'm not.
I see 4 specks. I saw 3 before.
No, those are all there. 1, 2, 3, 4, and there was a 5th one up here. There it is.
Okay. Noise.
All right. So, I just love the colors of the comet. You know, we're looking at the cyanogen halo and the molecular carbon, diatomic molecular carbon halo around the nucleus, known as the coma, C-O-M-A. And then we have our beautiful ion tail there. You'll notice the ion tails, it actually got some convolutions in it. It's not just a straight, even thing. It's torn up in a variety of places. You know? I want to say hello to Jenny Miko. Hi, Jen. How are you? I haven't talked to you in way too long. Simon Thompson, what's going on? How's it going in Australia tonight? Jenny, what do you think of the comet? Isn't that beautiful, Jen? Creeptasia, how are you? I'm doing well, thank you. I hope you are too. You like this comet? Look at that beautiful interloper. That's really something. This red is the edge of our wall. You can see right there, the edge of the building wall. So the telescope has to, rise up a little more, and that comes from making sure that as the night goes on, the telescope is going to lift up above that because it's going to follow the stars, and they're rotating around the pole, and it's going to bring the comet higher up in altitude. Hey, Greggy Gilgan. Oh, it's all right. Creeptasia says, doing well. Thank you for what you do. Hey, someone's got to stream the comet. But we're having a good time. It's fun. And we can see this ion tail, like I said, but also you notice this delineated thing here, and it's sort of yellowish. It'll show up better if I do this. You can see this kind of brownish dust halo here. This is actually the dust tail of the comet, but it's behind the comet coming at us. So it's kind of spread out because it's in the path of the comet as it's going. And the sun's energy does tend to push the dust a little bit, so it doesn't go directly behind the comet. It kind of drags off to the side a little bit, and that does happen. Mike has a question. How close are we in technology and science today from what you would have thought 30 years ago? We're never as far as we think we're going to be. Remember, we're supposed to have flying cars.
That's why I type bleeble, bleeble, bleeble.
That's right. Jen says something very interesting. She says, this is something to see, you know, a comet like this doesn't come around often. That's correct. This is a very, very nice, what we call an apparition, appearance of the comet. And it's somewhat rare. I'm not sure if we actually have the orbital elements of this comet yet. I don't know if we know if it's going to be a one-timer or a periodic comet. So until then, and I could have just missed it. I didn't see anything out there yet, and I could just be out of that loop maybe. But this is potentially a periodic comet, up to 50,000 years. It comes from out in the Oort cloud or the Oort belt as well. There's the way the solar system is laid out. Of course, we have the planets in a plane, right? And Pluto's a little higher and does a weird 17-degree elevation above the plane. And then just beyond Pluto is the beginning of the Kuiper belt, and the reason why Pluto was demoted, because we have a whole bunch of icy bodies out there in more of a plane going out, all around the sun, and Sedna's out there. We have these others. There's a number of them out there we've identified that are somewhat big, bigger, nowhere near the Earth, smaller than Pluto, and maybe there'll be more to be found. But then we also have another belt beyond that called the Oort belt. I didn't say cloud yet. I'm getting there. But there's another farther orbiting belt of icy bodies. And then around the solar system, spherically, is a cloud, an Oort cloud. And they're thinking that maybe this comet, ended up coming toward us from potentially that Oort cloud. Now, from that many thousands of astronomical units away, the thing that probably dislodged it from the Oort cloud and sent it hurtling toward us in the inner solar system was probably a passing star, millions of years ago. And that star probably dislodged it just a little bit, and it started it on that long trek into the inner solar system. So that's generally why or how things like that end up coming into the inner solar system, is they get dislodged by a passing star. But we see it and think that it just got here, and it's been on the way for thousands of millions of years potentially. So it's very possible that these comets come from a long way away. Okay, so I'm going to just save this here, and then save exactly as seen, and then clear it and get ready for the next one. The next exposure. And let's go to our inboard planetarium. Yes, we have a first quarter moon, and we're not going to deal with the moon tonight, obviously. So coming down here, you'll see, there we go, we are over here.
Comet's actually shifted quite a bit.
Mm-hmm.
In that image you see now, there's a line of a couple of stars under the comet, and
Yeah,
they were
right
to
there.
the comet's. They were to the comet's right a few minutes ago.
Yep. Indeed. So it's a very fast-moving object. So I'm gonna save this, so we have this one for a video, and then save exactly as seen. And then we'll let it develop a little bit, and we'll save that one, and then clear this for the next photo point for our video. Hey, Bucky Barnburner is here. What's going on, man? Good to see you. There are rough orbital elements, and he asked a question: if there are no ephemerides for, these, how can stellarium calculate its position? Well, to be truthful, stellarium can't calculate its position. And to give you an example, okay, if we look at our stellarium online, okay, it gives you a right ascension and declination, the coordinates right there for the comet. Well, guess what? They're wrong. If you go to those coordinates, the comet's not there. So you still have to hunt for it. But I'm showing you this because you get to see where the North Star is relative to the comet, and that's kind of where it is, right there. It's kind of a neat, image. And we can get rid of all the lines if we wanted to, and then you can just see the stars. There's the Big Dipper coming up, right? But at least we have these. Now we have two sets of lines. This is if you put a bowl over your head that had lines on it, with the top of the bowl being directly over your head. That's one way to calculate where you're looking, and it's called alt-azimuth. This is equatorial. This is the equatorial plane. This is the latitude and longitude lines of the Earth extended out into space. Except when you put them out in space, the latitude lines, these circular lines like this, those lines are actually right ascension, declination lines up to plus 90 down to 0 at the celestial equator. All right. So when we come back here and we go to Orion, all right, we see that 0 is right here, almost goes right through the belt. All right, and you see a 0 over here. You can't really see it, but it's there. And then it goes to plus 90, all right, which is right there where the North Star is. But not exactly where the North Star is. You notice the North Star, Polaris, is not on the North Pole. So that is just if you light up on Polaris, your telescope won't point to the right thing. So you have to point your star, your telescope to the actual pole. All right. That takes some calculations, and we can do that. Hello, Suzette Bavier. How are you? Okay, so let's go back to our view here. There's our comet. And we'll save this image. This is 3 minutes, 45 seconds. It seems like we go to 3 or 4 minutes and save it exactly as seen. All right. And then what we'll do is we'll clear it and check out the next position of the comet. You notice, as Daryl pointed out earlier, these 3 stars were under the comet, and now in the next photograph, when we take a picture, they're going to be a little to the left of the comet because the comet's heading that way. All right, which you'll see in just a minute. So we'll clear this. All right. We'll clear this. And we're 4 seconds from our next photo. There we go. And now look, those stars are now to the left of the comet. They weren't before, they were under it. Comet's moving fast. And I like this because this is literally showing us it's showing us how the universe is always actually in motion. It's really cool. So we're actually the comet's actually going in a direction like this. It's heading that way. Okay. So that's what we're
Robert,
seeing.
the comet was named after its discoverer. We talked about this a little earlier. The comet was discovered by the Zwicky Transient Facility, the ZTF, which is like a automated search program, and so its name is ZTF. There are several search programs going out there. Pan-STARRS is another one.
Yep.
And you'll see comets nowadays named Pan-STARRS, ZTF, etc., with a number after them.
I want to thank the over 70 of you that are watching right now. This is great. Wow.
Jeremy, the comet is moving up and to the right.
I had put a vector up there to show you which way it was going. I'll do it again. The comet is moving this way, up to the right, like that. If you watch, this is a static shot, a photo we've taken, and I'm gonna save it, and then we'll go back to an instant shot in a second. All right. So I can save it now, save exactly as seen, right? Then I'll clear, and then the next shot will come in. It's a 45-second photo. I'll let that wait until it's about to clear, until it's go through. Hey, Jeremy Blaine. Okay, so we'll clear it, and then you'll see the next frame will come in. We can then process and do a little processing, and then so here it comes. Bam! Look at that. All right. Let's zoom out a little because I don't want you to miss the tail of the comet that's out there. Look at that tail. It's huge. Okay, so we'll save this now. And we're saving this because Izabela is probably going to want to make a movie possibly. But the data will be there if she wants to get to it at some point. And we'll save it exactly as seen. Oh, yeah. Hey, Michael. Yeah, it's the chat is active. I like that very much. Oh yes, it was the TRAPPIST system that I remember. TRAPPIST was the name of the telescopes that they used. I think there were 8 of them, and I think the TRAPPIST facility was down in Chile. I'm not sure. I think it is, and I'm trying to remember what TRAPPIST stood for. It's if you can look it up, Daryl, I'm sure it's out there.
I could.
Yeah.
They love acronyms.
Yeah, we love acronyms. Come on, you know. Hey, acronyms are cool. They make you think. Okay. So as we see, the comet's getting the tail is becoming more well defined. And
Are you ready? Transiting planets and planetesimal small telescope south.
That's right. So it's in Chile. Hello there, M. Turner. How you doing?
Not that big a telescope, 60 centimeters.
No, there's more than one. I think there's 8 of them, and they're robotic, and they're actually they're in a cluster inside of a roll-off roof building. Oh, thank you, Izabela, for putting that up there. Hey, Levi, how you doing? Thank you for coming out, Levi. It's good to see you. Yep. Okay, so let's we'll save this again and save exactly a scene, and we'll clear it just in time for the next one to come in 2 seconds. Here we are, and let's do some processing and save it right away because we're just getting the position of it. All right, now we can play with some of these other features. Let's go over to the curve.
Bucky's asking about the ephemerides's again. Bucky, if you go over to the Comet ZTF page at the Sky Live and go to that page, I will include a link here. They offer an ephemeris calculator right there on the page. Says you can compute ephemerides for any date and time between January 2013 and December 2100. I will post the link. There you go. You can.
Oh, Sky Live, yeah.
Ephemerides to your heart's content.
So I just want to mention to everybody while we're watching the Comet, SkyTour LiveStream became an actual 501c3 not-for-profit corporation literally about 2 months ago, and we have a Patreon. If you go to skytourlive.org, you can get images that have been highly processed in a very, very professional manner, very high resolution, and you can put them anywhere on anything. And we've done some of that, and I'm going to show you what that looks like, okay? Because one of our members is someone that is actually doing this for us. Check this out. You can actually get mugs and carry bags and sweatshirts, okay? I'd like to get sweatshirts, and what's not shown here, sneakers with nebulae on them. I mean, it's really cool, So it's something that we're offering in a way to help bring in some donations and money to our cause, and this is just a fraction of the over 45 products that we have now. Look at that duffel bag. Check that out.
I want STLS underwear.
I'll look and see. Maybe they do boxers. I don't know. I think that'd be kind of fun. Anyway, I just want to show you that. We are a 501c3. We don't have prices on this. You can get a mouse pad. You can get a notebook. Look at that. You can get pictures for the wall. You can get prints. You can get stand-up card stock printed imagery. Look at the Flame Nebula. The Flaming Star Nebula. Travel mugs, tote bags, weekenders, anything you want. I am a fan of the orange mugs with the orange interior. Those are really sharp looking. So I'm going to have a number of those, I'm sure. But anyway, this is not trying to just hawk products, okay? Trust me, we're doing our best to find monies where we can to help bring this to you. But if you're interested in any of these products, you can find us at skytourlive.org. Those will be available soon. We're going to be hooking up and we'll be selling these products online in a variety of places, including, it looks like, Walmart. I think we're going to be offering these on Walmart online. So that'd be kind of cool. So a number of places. So you will see. But if you have a favorite object and it's not visible or not listed, we make it. We'll make it for you on the fly, and you'll get one. So if you have a particular object that we've taken, like the Orion Nebula, well, we don't have an Orion Nebula travel mug. We'll make you one, and we'll have it ready for you. So that's the kind of thing that we'll do. Look at Suzette Bavier. I want 2 sweatshirts. Yeah, me too. We need them around here. That's cool. So we'll keep you posted on the availability of all this stuff in the short order. But remember, SkyTourLive.org is where you go to. That's our portal. You'll find the link up on the left brings you to SkyTour LiveStream, which is this, and the link over on the right will bring you to the Patreon, where you can select the level and maybe do some stuff there. And yes, Michael, there's hats as well. We just didn't put them up here. We can't show, like I said, there's over 45 products that we've already been developing to put out there yet. And the other thing too is we're also looking for volunteers to help within SkyTour Livestream. And if you do some significant work for us in return, you'll get some of this swag for yourselves. We'll get that for you as well. There will be things like we need someone to write a front-end application, either for an iPhone or Android or the computer or all three, to be able to allow you to access our database that we're building. And that database will allow you to find out where and when we photograph things like a comet, or whenever we looked at the Orion Nebula, or when we looked at the Elephant Trunk Nebula. And you'll see every one of those, including pictures on the database on our live server. So you can go sifting through the server now manually, but we want to get a program written to actually do the searches and show people all the things they're asking for. Again, for the phone and for the PC and the Mac. So we're looking for all that. Yeah, we want the sun, the moon, and the stars, but only the ones we photographed.
Time to update yet?
Yeah,
See how far the comet's moved past that line of stars?
Oh yeah. I just wanted to get some more of this dust tail here. Look at this. This is really resolving beautifully, but it's moving with it, so it's wider than it should be. So I'm going to save this right now, and then I'm going to save exactly as seen. And we have 15 seconds or so until the next shot, so I'll clear it just before then. We're down to 10 seconds left, so I'll clear it and we'll take the next shot. And we're going to have to move the comet a little bit, or move it the telescope to capture everything. So what we're going to do is we'll save this. Well, actually, no, I'm going to wait. I'll tell you why. I'm going to go back to our 1 second night vision mode. And I'm going to go in here and I'm going to move this so the comet is back in the shot. Because that's how much it's moved, right? And now we have to move it to the east in order to... no, actually, we got to move to the west, don't we?
The other east.
Yeah. So we have to go this way to show the whole tail of the comet. It's moving so fast that now when we take a 42-second exposure, it kind of causes problems. It actually blurs a little. Sort of reminiscent of when the Event Horizon telescope was taking pictures of black holes. Material's moving so fast that it ends up being kind of blurry. So the tail is going to be right here, I think. So let's go back to do a 42-second exposure. But see that tiny star right there? Let's just go watch, because this is it's gonna move right over that star. Check it out. All right.
Quite a ways.
Yeah, you're gonna see it move. That's what I love about this. So watch this star right there. That guy. Keep your eye on that star. I'll remove this here. I hope you guys don't mind my my little red highlighting and things like that. I am thinking that maybe that's gonna make things clearer at times and easier to decipher what I'm talking about.
Michael Hedrick, I don't know the answer to that.
Are any comets or asteroids radioactive? Michael Hedrick asks. Technically, there's no reason that they may not be. It depends what elements they were made with when they formed. Earth was made with radioactive elements that when during differentiation, when the Earth formed from a molten mass, the heavier elements sunk to the center, and that's part of the reason why the Earth's core is as hot as it is, because of the radioactive, nuclear pile that's down there, the natural nuclear pile. But with other objects, it's possible that they have radioactive elements, down in their cores. If they're big enough, like Ceres, the asteroid Ceres, may have a radioactive suite of elements down there. Hello, Jane Murdoch. Oh, you've seen nothing. She says, great fun, great pictures. Oh, you're signing off? No way. You got to see a picture first. All right. Don't go anywhere yet. Hold on, Jane. Let me just get you one shot here.
Isabella's leaving. Say goodbye.
What? Why is she
She's
leaving?
leaving. She's tired.
Oh, Izabela. All right. I'm sorry. I guess it is very late for her.
Give Sky a scritch for me.
Thank you, Izabela. Good to see you. Okay, 45 seconds. And we'll stack this. That's the old one. We'll clear that. And we'll get rid of this here. Hello, Gabrielle. How are you? Anthony Glenn Norman, how are you? Look at that. That's beautiful. Oh, pretty. This is just gorgeous. Alright, so we'll save this. Save exactly as seen. Schaefer Studios, what's going on, man? Good to see you. Boy, look at that tail. I mean, you can see there's some real complexity in that tail, Daryl.
Uh-huh.
And this yellow, the distinctive color of the dust tail, you can clearly see this dust tail behind the head of the comet here.
Yeah. I think we must be clear of the wall now. We're close to it. And if you look closely at the comet's tail, a little ways to the lower right of the nucleus. Whoops.
That's temporary. Let's do. That's weird.
I was going to say you can see a notch in the tail, but
Yeah, I'm thinking that we had some weird interference there. You mean here?
no. Keep going up to the left, up and to the left. Right there.
Oh, right here, like this little. You can see
On the top side of the comet tail.
right here. Let's go in. Let's check it out.
I see a little notch right there.
Let's go see.
Right above there.
Oh, I see it. You're talking about this little guy right here.
Well, no, actually, just to the
Okay, I
left of
guess-
that star.
All right.
Not a big deal.
Okay, I had to zoom back out here. I do see there is something there. You're right.
Yeah. Just a little thing.
Yeah. Jason, always ready. How you doing? Oh, it's okay. Whenever we have big streams, like we have big streams with eclipses and things, people will always go off sometimes, and that's fine. Not a problem. Okay.
Oh, my tea is cold.
Alright, I'm going to save this like this, and then save it exactly as seen, and clear it quickly, just in time for the next image.
Michael Hedrick has a question of you.
Alright, I will save it again, and save it exactly as seen. Marc, is it normal to discover a comet so near the time of its arrival?
It was discovered last year.
Yeah, remember the name, Michael. The name. Well, actually, you know what? It's not your fault. I took the name off. Let me throw that back out there for you. This is Comet 2022. It's C/2022 E3 ZTF. So technically, I should be doing this.
Sometimes they see comets way out there on the way in, and sometimes they kind of sneak in close before they find them.
That's right. Hey, Marty.
And
Gerlach.
again, in this case, it was an automatic search program that found it.
Yeah. Hey, Mike Hurley. Mike Hurley has a question. What scopes are you using? Or what scope are you using? It's right there. Let me actually see if I can give you a bigger view of it. Okay, this is our scope right here. This is a 10-inch system. We have a camera, though, that's up in the front. All right, there's the front. It's looking over the outside, toward the north, actually, of the building out there. And the light comes in, goes down to a main mirror, then goes out through the front of the telescope, through a lens system, right to the camera. So the camera's on the front of the telescope. So we're actually running an F8 system at F2. So it's 25 times faster than an F8. And we can take photographs of things that are pretty faint and do it in seconds rather than many minutes. So it's actually kind of cool, So, not bad. Okay, we're gonna go a little longer here with this. Doc from Wyoming, how's it going?
Mark, excuse me a moment, please.
Sure. I was in Wyoming at Devil's Tower 2 years in a row. I was speaking at the Devil's Tower UFO Rendezvous, put on by Robert Olson and Lori Tucker. And it was very well attended. People really enjoyed it. So we had a good time there. It was my first time of seeing Devil's Tower. And then the next year I was prepared and I was able to get a nice hike in around the tower. It's a giant exposed lava intrusion. You know, it's not a tree. I know it looks like a tree, but the tower is over 800 feet above your head when you're standing at the base of it, and that's where the ground was. And it got weathered down over time, exposing the harder rock in the middle, which is that Devil's Tower. And the reason it has that shape is because this particular molten material, which was not basalt, okay, it was a different lava, but like basalt, when it cools underground, it'll form giant crystalline structures, six-sided shapes, and that's why Devil's Tower has these large fluted outside areas. It looks just like these fluted six-sided shapes, and those are actual geologic crystals, and they're like 10, 11, 12 feet across. It's incredible. All right, let's see here. Ronald from ERT Radio says, how many percentage, well, I'm not sure that's what he meant, is the quality of the photography using this new technology compared to the old days? Oh, what kind of an improvement? Oh, easily 10,000%. We're seeing details that you just normally don't see, you know? All right, let's get the next data point here. That's a beautiful comet. Without a doubt, that's a beautiful comet. Just a second. There we are. Okay, so we can clear this now and get our next exposure ready. And it's kind of funny when you're watching a comet to actually see that you actually have to move the telescope to follow it, because over time it's actually moving out of the field. We're used to that with the moon, but not with this guy, right? This comet right here. But look at it go. It's moving out of the field already. Beautiful. All right, we'll save this again.
M. Turner, we did last night, but it might have been the speed of the comet. I'm not sure if it would have been at perihelion or when it's closest to Earth. It was a little bit over 200,000 kilometers an hour, or about 120,000 miles an hour.
So not very fast.
Yeah.
Hey, Carbon Star, how you doing? let's do something here. Let's drop this down and let's get rid of our telescope for a bit and bring this full screen here. That's more like it. All right. That's more like it. Okay. So that's pretty cool. Look at that tail. Beautiful. And a dust tail here. A fan behind the comet that you're used to seeing. As the comet moves through space, it leaves this dust behind. And the solar energy also gives it a little push. But for the most part, it stays in the path that the comet's moving. And then if we are lucky enough to pass through it at some point, then we will see a meteor shower due to it. This comet, probably not, because we are actually... this comet's not passing close enough to us to actually intersect our orbit. There's my telescope back again. And we'll get the stack here. And I will save it. And save it exactly as seen.
Mark, did you see my message from last night about High Point Scientific?
Oh, doing the stream?
Yeah, their stream started just after local midnight last night. And
okay.
Their image with all their high-priced equipment, you know, they're telescope sellers is what they are, telescope astronomy store.
Yeah.
Their image didn't hold a candle to yours.
Really?
Yep.
Well, they might have had poor weather or poor seeing. But that's interesting, actually. I mean...
it looked like they were using a small telescope.
I mean, we do have
and
the advantage here.
I think they said they were... their live stream was coming from Tampa, Florida, which might have been a factor also, but it just you couldn't see a tail. You really couldn't see much of a coma around the comet.
So you're saying that maybe it... I'll try and approximate what they maybe showed. Something along like this, maybe?
Smaller. No tail at all.
Oh, okay.
It just wasn't a very good image. I was surprised.
Well, Tampa's a light polluted city, so I can understand.
Yeah.
This telescope right here you see, we got from High Point Scientific. So I worked with them to get the best telescope, and then we had Starizona down in Tucson, Arizona, modify it to actually put the system on it to give us f2, 25 times faster photographically. And that telescope you see right there is the only one in the world currently that has this modification to be that fast. It's the only one like it, I should say. Now, there's other telescopes that have the modification to f2, but for the Meade system that we have, we were the prototype. There's no others like that, so we're the only one so far. So I think that's pretty cool.
I didn't know that. I thought you got the scope from Arizona, Starizona too.
No, I got the scope from High Point. In fact, it was SkyTour LiveStream East telescope for a period of time. And I worked out all the bugs for the remote operation here. I wrote all the programming to run the building from here. Then we built the building out there, courtesy of Tara and Marianne's diligence as well. And then I ended up moving the telescope from here all the way to Arizona. And to do that, I actually had a friend, Keith from P&K Space Imaging. He had a trucking company, and he actually came up here from Pennsylvania, picked it up, packed it up, drove it all the way to Arizona. It was like 2 days later he showed up at Marianne's storage to put it in the storage for transport out to the building and installation. We installed it, and on day one when we installed it, we turned it on, and it started going, it started spinning around. I was like, whoa, something was definitely screwed up. So
I remember that.
So we packed it up all over again and drove it down to Tucson, Arizona, to Star, Arizona, and met with Dean Koenig, and very good guy. And Dean, he looked at it and said, okay, I have a guy here that can fix it. And the guy David down there, he went through it with a fine-tooth comb and he fixed it. He literally had to go into the circuit board on the motherboard in that telescope and fix solder joints that had broken loose, which I thought was pretty cool. And so he did it. It worked fine. It's still working fine. We did have to bring it back for another issue that we had, which he took care of as well. And now we are in the happy time where everything's working. So when something is remote like this, okay, this telescope right there is 2,500 miles from here, and I'm running it from Connecticut on the opposite side of the United States, and it's out in the Arizona desert. So that's what we're all about. We're all about remote astronomy, remote observation and photography and data gathering this way, and that's what works, and it's working just great.
That was me knocking on wood.
Oh, that's what I heard.
Yep.
Yeah, I should knock louder. Boom, 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 boom. All right, so we're gonna clear this one, and
That line of 3 stars, see how far it's moved away from it now?
yeah, these 3 stars you were talking about are these guys.
Yes.
Yeah, it was right there.
They were to the left of that. Now they're to the upper right.
Yeah, the comet is definitely moving up. Now you're thinking it's going that way, right? So you're thinking, why is the tail going this way? It looks like the comet's speeding to the upper left, but it's not true. This is the ions driven off the nucleus of the comet by the sun, heading down away from the sun, directly away from the sun. It's independent of the comet's movement through the sky. So that's the first thing you got to get over, is that's going to happen. Shaver Studio says, glad I found your channel. Love this. Oh, fantastic. We do deep sky objects normally, and when there's a comet, we'll check it out. And tonight, we've actually done the comet for most of the time so far, actually all the time. We could take a break and go check out another object real quick and then jump back to the comet, give it time to come up more above the building, and we can do that. But I want to just do one more object here. This is a 6-minute exposure, so it's moved 6 minutes worth of time, which is quite a lot. But we'll save it exactly as seen, and then when we get close, we'll take another quick image and take a picture of that. Hey Sharon Cardick, how are you? Good to see you. And if you look where I'm looking, I mean, this is the broadcast screen to my right side, and this is the observatory feed. So I have 2 screens, and so you're seeing me looking left and right, so, but never always in the camera, so I apologize for that. Okay, so now what we'll do is move this up and prepare for the next exposure. This one we'll clear this, and we have like 6 seconds here, so we reset the stack and we're gonna stack it. We're gonna do this again, but here we go. Boom, we should see our new cometary image. There it is. And that is even though it's a little noisy, it's the most accurate one of the images right now because it hasn't moved much.
Say what?
It's moved 45 seconds worth. It hasn't moved like 6 minutes worth.
Oh. Okay, may want to bump the field to the upper right next time.
I guess I'm gonna have to. Okay. Okay.
Yes, Sam. You want to take a break from the comet? Sam is asking about the Crab Nebula.
Sure, we can look at that. As you can see, we do take requests, and we do and will take a break from the comet here. We can do that. Let's pull that out of there. This will be there, and we'll come back and we'll catch it when it's even more above, and we might do a nice deep shot to try and catch more of this tail. All right. So that said, we're gonna go into our night vision mode. Helps us find things very easily. All right. So here we go. There's our night vision mode, and we'll go into our system that's tied to our telescope.
I think the tail's over 5 degrees long now.
Yeah,
when you come back, hit the head right up in the top left-hand corner, and
we still won't have all of the tail.
Yep.
All right. All right. So let's do. We'll say find. And okay, I'll type it in. Crab is beautiful. Crab is a supernova remnant, which is just beautiful, known as Messier 1. Alright, there it is. And now we'll tell the telescope to go there. So you'll say goodbye to the comet for a few minutes. There goes the telescope, swinging around. And it's going to point almost exactly at the crab, I'm going to guess. Might have a slight adjustment to make. The crab is actually pretty high up right now. There it is. That's the Crab Nebula, and we'll find it. Jose Mortaya, how are you? And I will bring it down into the field a little more. Alright, and we'll head east a little bit too. Fred Saunders, how are you? ¿Qué dirección hay que mirar para verlo? It's just to the right of and below Polaris. It's down. Actually, I can show you exactly. He wants to know where to look for it. Let me show you. All right. Let me just quickly go here. We'll get back to the crab in just a second. But, alright. This is Ursa Minor. Okay, the Little Dipper. There's Polaris right there, okay? So, Fred, it's just to the right and down just a little bit from Polaris. And that distance you're looking at is, what's that, 20 degrees? 22 degrees, maybe? Something like that. So, it's not too far away, but it's actually, if you look at right now in the sky, if you look for Kochab, the N star, these two stars, okay, actually kind of sort of point toward it. All right, in the Little Dipper. This is the Little Dipper right here, and they point right toward it. All right. Hopefully that is helpful to you. If you have any more questions, I'll be happy to answer them.
We're going to break away from the comet for a bit and look at the Crab Nebula.
Yeah, we're at the Crab Nebula now. We've been looking at the comet all night so far. In fact, it's the only object we had in here. But we'll just do this now and grab this. Okay.
Welcome, Tricia.
Hello, Tricia Ferreira. How are you? Oh, thank you for subscribing. Seattle. Yeah, no clouds. Wow. That's pretty amazing because obviously Seattle has been known to be very cloudy. But I'm glad. All right. So this should stop right about here. That's good. And now what we do is we're waiting for our guiding system. It's saying searching. When it actually locks on, we'll see it go 0.0.0.0, and then it begins the guiding process. Here it is. It's calibrated, and now it'll start guiding. And we're going to set up a exposure here. And the exposure we'll set up will be, we can do a 35-second shot. This is actually pretty bright for this telescope. Alright, we're going to let it stabilize first. Okay, just waiting to get our Starlink satellites back. All right, 35 seconds. And we are good to go. So we'll be stacking that. We're working on getting rid of delays. We're using Starlink, but it's still has delays. There's the comet. We're gonna clear this and then move into our exposure here, which we're doing now. That was the buffer of the last image. Okay, so here comes the first image of the Crab Nebula. Okay, let's show that. All right, then we can zoom in on that a little bit. Okay, the Crab Nebula. Now, the first image is always a little grainy. When you see the second one come in, a lot of this noise in the black space is going to get toned down and be gone, and you'll see more detail in the Crab Nebula. Notice the filaments in there. This was a Type 2 supernova explosion, meaning a core collapse supernova. The star's core collapsed, and literally the star blew up from this. Okay, and this is actually a beautiful shot, considering the moon is out. And we can color correct this as well. All right, and I'm gonna do that. And now, if we zoom in some more, okay, you'll see something inside there. See that right there? That little tiny dot? That little dot is a star, but what it is actually is the Crab pulsar. So that right there, that little white thing you see there, that is a neutron star, the remnant of a supernova explosion, but it has hot spots on its surface. So, and it's rapidly rotating at 33 times per second. And this is a star the size of Manhattan Island, okay? And that star is rotating so rapidly that it flashes us 33 times per second with this hot spot on its surface. And that's what a pulsar does. It's called a pulsar because of this. Now, as far as being a pulsar, it's not even the quickest pulsar we know. The fastest pulsar we know goes over 700 times per second. A star, spherical star the size of Manhattan Island, spins 700 times per second. It seems literally impossible to comprehend that, because you would imagine a star would just fly apart. But it doesn't, because it's so dense and has such a high gravitational field.
And it's over 1,000 miles away, if I remember correctly. And it's only the size of Manhattan Island, and you can still see it.
You mean light years, not miles.
Oh, excuse me, light years, yes.
I was wondering where you were going. Yeah.
I'm losing my mind.
No, it's okay. It's late for you. Well, it's late for me, too. Actually, it's later for me than it is for you. Because you're in Colorado. So there is the Crab Nebula. And you'll see these colors around the edges. This green, this is doubly ionized oxygen. The red is ionized hydrogen gas. Okay? Hydrogen only has one electron, and it can only ionize one electron, so it's only singly ionized ever. So that's pretty cool. And let's see if we can extract some more data here. Yeah, pump that down there. There we go. And then let's see if we can move this down a little bit.
You see all the filaments inside the nebula. If you look up the Hubble image of the crab, there are millions of filaments like that inside the nebula.
That's right.
Very complex.
Yeah. So that's what it is right there. Supernova remnant.
I forget, how far away is the crab?
You'll have to look it up, because I don't remember. I thought it was like 6,000 light years sticks in my head, you know. But
yeah, when I said 1,000, I guess that's when we actually saw it in 1054 AD.
Yeah, 1054 AD is when it was seen. That's when the light train finally reached us.
It's like 6,000 or 7,000, I think.
Yeah. Sam S. says, is noise ever good data? That's the nice thing about this, Sam. In the case of doing astronomical photography, if you have like a dark nebula, the dark nebula is the signal, right? But sometimes when you take a picture of this dark nebula, you're going to see it looks kind of mottled and has color banding and stuff, and that's noise. Well, noise is never good, but if you're taking more than one exposure, what we do is we take an exposure, we stack multiple exposures on top of each other after aligning them perfectly together. And when we do that, we're doing that now, right? In fact, over here, we've actually stacked 10 images of the crab. It says so right there. See? Right there. Okay? And what is happening is that stacked image, what it does is anything faint that's data is going to not move. It's going to stay there. So the more images we stack, the bigger that peak of the data shows up and gets bigger. So we'll actually see more data in our final result. Even if it's dark data, the color of space, it will show up if it's data. If it's noise, it's just going to get lost and averaged out, because the noise isn't the same for each frame.
Yeah, the crab is 6,500 light years away.
I thought it was far. Yeah, I thought it was far. Okay, we've done 11 here, so we're going to pause on that, and what I'm going to do is I'm going to save it because it was a requested image. So it's the Crab Nebula, and when I hit save now, you'll see our astronomical file format across the top. But then if I say save exactly as seen, you see this when he gets out to the server. All right, so basically, this, for instance, this is the image that's going up to the server as we speak. It'll be there in probably 25 seconds or less. And you go to SkyTourLive.org and you scroll down, and you'll see, take me to the really cool pictures, and read the instructions there, and it'll take you to our database, and you can go down into our directories and see this very image and take all the images and do what you want with them, you know. For our patrons, the people that sign up for the Patreon, for the higher tiers, you actually get access to the highly processed, properly finished processed images that you can turn around and have printed in a variety of ways, and it's just beautiful. Or you can just explore them and look for things in there. Hey, Fawn Burgess, how are you? Go ahead, Daryl.
There is a direct link to Marc's server where tonight's images are landing.
Yeah. They'll all be there, and you can get to them from SkyTourLive.org. Remember, SkyTourLive.org. That's our portal. You know, if you go to the upper left, you'll see a link to SkyTour LiveStream, which is this. If you go to the right, you see a link to our Patreon, which is that. So you could join our Patreon if you want. I want to thank our patrons. We have Ali B, we have Chief Max Cyber, Vera Lucia Campos, we have Ronald T, Martin W, and Raymond B. And there's room for so many more. Please join us in our Patreon for as little as $5 a month, or, well, you can go see for yourself. There's upper tiers as well, where for the highest tier you actually get a guided tour of objects for you that you might want, and you can tell us what you want. If you don't know what you want, we'll help you figure out something cool, and then we produce a very highly processed image just for you. So that's pretty cool. All right, so what we'll do here is we've done 16 of these. We're going to pause and save it. I only did a 35-second shot of this. Can you imagine if we did more? You won't see much more detail, but the center would get washed out. This is just about the limit. And we can actually show more detail inside by doing this. So now you can actually see that pulsar in there. See that? Very cool. And then we'll let it process back, and that's what it wants to do. All right, so what we'll do now is I'm going to pull this down. I'm going to pull this over. Wait, I'm going to go this way. Okay. So now we'll save it. And then we'll save it exactly as seen. Ta-da! There we go. And now go back to our night vision mode, which I think will be helpful for our next search. All right. Now, where we are is in here. This is Taurus, the bull. And these are the horns of Taurus, the bull, which you can see. We show you the mythology. There's the horns. Okay. And let's go now Well, actually, while we're here, let's check out the most beautiful cluster in the winter sky, arguably. This one is called Messier 35, and it's actually a very pretty cluster.
We will be getting back to the comet, folks.
Yes, we will. We're waiting for the comet to rise further above so we could do a deeper exposure and see a most beautiful object. So lots more detail to be had. Okay. I see where we are. I think I
top
grabbed,
left. Isn't it?
yeah, it is. I think I grabbed the wrong cluster. My mistake. I did. That's okay. We'll get there now. It's gonna come down now. This is Messier 35, and this is NGC 2178, a tiny, more distant cluster. I shouldn't say tiny, it could be this big if we got there. But it's actually quite a nice cluster. So we'll bring this down. So this is Messier 35, also known as M35. And it's in the constellation Gemini, and we call it an open cluster of stars. Alright, so there we go. So I'll remove that for now, and let's just do a 30-second shot of this. No, I don't have to. We can do a 20-second shot. It's a very bright cluster. Alright, so off we go, and we're guiding. So we go into our live stack and clear the last buffer with the Crab Nebula. Good night, Cyclone. Thank you for coming.
When we look at M35 here, the little star cluster on the right is far, far in the background. It's much farther away than M35 itself is.
Yeah, this is the NGC 2178 that we talked about before. Very nice. Isn't that beautiful? Let me just do a little processing here. I'm going to take my black level, which is represented by this line, and move it over to kind of darken up the field a little. Not bad. Yep. And one thing you'll see too is you'll see that there are many satellites that will be going through the field. We haven't had too many tonight. Before I started, and before I went live, I had some satellites going through, but we haven't seen any yet. But they'll leave a line because they're over like the exposure time of 20 seconds or so over here. You'll see that they do that. And speaking of the things to look at, all right, this value right here is the exposure. That's one of the most important ones. And then right down here, the next one that's most important is the gain. The gain is the sensitivity of the sensor. Okay, right now we're at 300, as you can see. So these two values are the ones that we play with a lot. All right. We can also use the histograms, which give us the data, curves. So if I was to do this, for instance, we'll see what else is there. You'll see that it'll brighten up tremendously. Okay, but we're not seeing any more stars. We're just adding an incorrect amount of brightness to the black of space in this case. So this is 8 stacked, and that's enough for this guy. So we'll change the name up here to
We see,
M35.
and you see 2158 there to the right.
Oh, is it 2158 or 2170? Was I calling it the wrong thing?
I think it's 58. That's about
Right.
9,000 light years away, and M35 itself is about 3,000 light years away. So you see it's much farther away.
Yeah.
Looks much redder tonight, too.
Yeah, now that red color is due to a couple things. First of all, space is black, so the color's been adjusted properly. Why is this red versus this, which is not? Is it made of red stars? The answer is no, not necessarily. But we're seeing it through more stuff in the galaxy, dust, and that galactic dust will, in most cases, redden the starlight. Why? For the same reason that our sky is blue. And you say, what? When the sky is blue at sunset, well, the sky is blue, and at sunset, what color is the sun? It's red. Why? Because the bright blue light from the sun is being scattered by the molecules in our atmosphere. Okay? And so dust will scatter in space, dust will scatter the blue particles as well, especially if it's small. Small particles will scatter blue light very efficiently. So these stars could have the same color as this, all right? But because they're coming through some black dust and being seen through the dust, their light is more red. Interstellar reddening, it's called. And when I was getting my degree in astronomy, we had to calculate interstellar reddening and make sure that we accounted for it when we did observations of stars, you know. And so that was something. That was a real pain too, because you had to figure out if the star was unknown. You had to figure out, you know, how far it was from known data if we had it, and then from there you had to figure out what kind of dust was between us, and come up with a calculation to remove the reddening and get the actual color of the star. So anyway, that's how that worked. It's pretty cool. So let's save this as it is and save exactly as seen, and we'll clear this buffer the next time in. Alright, so now let's go back to night vision mode and find another object to check out. Yes, I see.
I asked for Orion Nebula earlier.
And I'm thinking that's probably a Dia right now. Alright, so let's go down here. Over here. And Orion is actually getting pretty low. It's a really kind of, you know, not a good thing, but it's getting lower. There's Rigel right there. Alright. So the Orion Nebula is down here. Alright. And we are going to go there now. So are you ready? This is a beautiful object. Alright, so as we come down, you can see how bright the Orion Nebula is. It's one of the brightest nebulae, if not the brightest nebulae in the sky. Alice Pooper, we're going to get back to the Comet in just a little while. We're just taking a break. We've been on it all night, and we're going to go back to it shortly. I just wanted to give it time to rise up more above the building wall. We've been able to see it. Okay. So this is the Orion Nebula. Throw that out there. It's an emission nebula. And we'll head east a little bit. There we go. Now, remember that thing I told you about satellites? Yeah, this is where you're going to see them. Okay? This is where you're going to see them. Let's take the name out for just a second here. All right, and head north a little bit.
I see one right now.
I bet you do. Let me see if I can move up to get the running man in here.
Going right through the Orion Nebula there. Just about center right now.
In here?
A little bit down to the left. Passing that star right now.
There's a lot of stars. I see it right there. Yeah, see, there's a satellite right there. Let's try something. Let's turn off the tracking for a minute. Okay, so now the tracking's turned off, and we're going to see the stars trail. Meaning they're going to start drifting. And notice this star, this object here, isn't moving. Do you know why?
I think it is still moving.
Well, if it is, it's moving slightly. It's really pretty far out there. It means that this is actually pretty close to being... Oh, Starlock is still trying to guide. It means that the nebula... I'm sorry. It means that the satellite that we're seeing there is very far out, and could be close to 10, 12,000 miles out. Geostationary orbit's around 22,500. At that point, when we stop the tracking, any satellites that you see making a trail, the trail, of course, are fainter because these are very faint when they're at geostationary level. The trail will turn into a dot, and the nebula will start moving. I'd have to turn off the guider to make it do it, but that's okay. We're guiding again, and what I'm going to do now is, here's the Orion Nebula. Let's do a fun exposure of just 5 seconds. All right, 5 seconds exposure, and we'll live stack it. Clear this. And now check out the Orion Nebula. Okay, you say, wow, that's really colorful, but let's process it and get it right. So let's also color correct. There's the Orion Nebula, just like you might be somewhat used to seeing it if you've seen it before. Now, inside the Orion Nebula, there is a set of 4 stars, among a few others, that's actually powering this nebula. And it's already overexposed. We can't see it, okay? But that's a beautiful nebula, right? And these are satellite trails. Okay, so what I'll do now is, instead of the 5-second exposure, we're going to go to a 35-second exposure. And I'll show you what's really hanging out in this region. Okay. So we'll be looking at this region right here, and you're going to see that there's an awful lot of stuff here that you just don't see. All right, so let's first bring this over. We have 15 seconds, but see all that dust? Okay. Now, that's a 5-second exposure with this telescope. So let's clear this now and see the full 35-second exposure. You ready? Okay. Doesn't look much different, does it? Well, it will once we actually do the processing. Let me get to this. All right, here we go. All right. So now we'll color correct. Whoa, look at that. Suddenly, there's a lot more dust. Okay, look at this little finger of dust out here. Look at these clouds, billowing clouds. Look at here, look in here. Look at this beautiful series of dust clouds in here. Look at this tiny satellite trail in here as well. Now we have our first quarter moon out, so the fact that we're seeing this is actually pretty good. Okay, so there we go. Make it a little more contrasty. Isn't that cool? So that's the Orion Nebula as it is now with Orion, as it is with, not Ryan, Orion. There we go. This one up here is called the Running Man. And kind of because there's an emission nebula inside, kind of like the Red Orion Nebula, that looks like a running man. Now it looks sort of magenta in color because we're seeing it through a blue nebula. So when you take red light and mix it with some blue light, well, the red light kind of looks magenta. But look at these beautiful clouds. Aren't they stunning? Look at all that stuff. Let me zoom in now on my curve and do a deeper modification here. So this dark brown dust that you see, this is dust. This is literally what basically made the stars and planets. This stuff made the Earth over time. Not this very particular one, but over time, these are little pieces of dust, silicon atoms and dust particles, carbon dust, other materials. We've got methanol, formaldehyde ice, and ammonia, water ice, carbon dioxide ice, and all kinds of other elements made in the hearts of stars before it that have been scattered to the interstellar medium by supernovae. And that's what we're seeing here, is that scattered remnant, the scattered stuff. And then when stars form, they light up a nebula, right? And they're mixed with hydrogen gas, so that we'll see these amazing red tendrils of hydrogen alpha, it's called, or glowing hydrogen gas. So the interstellar medium has a bunch of really amazing phenomena for us to see. And this is an example of it. So we've stacked 6 of these right here. That's not bad. Okay. Any questions, let me know in the chat. Robert Waters, thank you. I'm glad you could stop by. Thank you for hanging out for the Comet and for the Orion Nebula and the Running Man. We'll talk to you again. Good to see you. All right, so look at that beautiful, beautiful nebula. Very subtle detail too. It's just gorgeous. Okay, we're gonna go to 8 stacked, and then we'll save it here. Hey there, Papa Tom. I didn't say hi to you earlier. I apologize. Here we go. So now we'll pause and save this, and save it exactly as seen. All right. Well, there we go. And before we go, let's just zoom in on this central area. Look at this. Look at all this dust. It's quite amazing. There's a Running Man Nebula.
Oh, fuck.
Yeah, right. Stick around.
Did he say that in the Running Man?
Nope. He said crazy things like he stuck someone to the wall with a post and said, "Stick around."
I thought that was Commando.
What's it?
Yeah.
He might have done it in more than one place, because when he's being chased, the way he killed his attackers, he had a funny line, like when the when the electrical guy, he shocked him, didn't he say, what happened to so-and-so? He was pretty shocked, or something like that, or he got shocked, or whatever. Or he had a shocking experience, I don't know.
Well, I'll be back was
Terminator.
yeah, that came from the Terminator, and then he started saying that in a lot of stuff.
Huh. Nice. Okay, we already saved it, so now we'll get rid of it. And look at that. How beautiful. Alright. And now, you see satellite trails out there. Should we go back to the Comet?
Absolutely.
Okay, we gotta get its coordinates. If I take the coordinates of it from Stellarium, meteor, it's 12 hours, 38 minutes, 17. 12:38, 17. So we'll come here. 12:38, 17. And then the declination, or altitude, astronomically, is 78, 19, 35. 78, 19, 35. And that won't put it exactly where we want to go. We have to go further north from that. So we'll try it. Okay. Let's do this. Okay.
You can't just click on a Comet and Stellarium and it'll go there?
Not that Stellarium.
Oh, okay.
78, 19, 35. Okay. And then we'll say go to. And the telescope will be swinging around for a little bit. And while it's doing that, there it goes. While it's doing that, we'll find when it gets back to it, we're going to have to go hunting and go a little bit north, because Stellarium didn't have the right coordinates for the online version of Stellarium. Alright, so now we're gonna swing up north, and we should find it now up here.
Should you back out on your zoom?
We're at 33%.
There it is.
Okay. Now we know better than to, center it, because we know the tail's going to be way off. It looks like it's clear of the building, so we can have some fun with this now.
Yeah, the angle of the dangle on that tail earlier.
Mm-hmm.
If you put the head of the Comet up in the upper left-hand corner,
That's where I'm going.
the tail should be pointing down to the lower right-hand corner.
Yeah. It's a long tail. It's going to be longer than the screen size we have.
Yeah.
Folks, keep in mind that the size of our screen here, or our field of view in the telescope, is 4 full moons across and 3 full moons tall. So it's over 2 degrees and just over 1.5 degrees. It's big.
See how far it's moved from those 3 stars on the left?
Right here, yeah. Moved quite a lot. So let's,
nice little asterism there on the right.
yeah. Alright, so here's what we're going to do. We're going to actually go up to 350, a higher sensitivity. And then we'll do a 50-second shot. Now, it will move during that time, yes. But we want to check out the tail.
Let's see if I can find that
There we go.
neat little group of stars.
Down here?
Yeah, that one at the lower right.
Yeah. All right. That's our Orion Nebula buffer. And we will clear that. That's going to be up on the server. I just saved it, remember? So you can check it out up there. Hey, Taryn Marie. That was the Orion Nebula we shot earlier, just a few minutes ago. Sam S says he always sees a rabbit head in that dark nebula. That's kind of funny. 10 seconds away from our comet image. Alright, let's process and get that. Wow, look at that. Okay. So,
yep, that's it.
What star is those?
I'm looking on the sky live, and I can see it there, I think, but they don't name it.
Okay, I'm sure I can find it. Let's go up north. Go here. Center it up.
Comet's about the same elevation as Polaris now.
Almost, yeah. Okay. Now you see the writing? That's the angle that you have to look at it, all right? So right now, this is where we're looking, all right? So the tail of the comet's going down like this. That's pointing to where the sun is out in the 3 space, if you could imagine how 3 space looks. Alright, so if we're here, those 2 stars down here, come back out.
Are
they there?
Oh, you're trying to identify that little asterism I mentioned? That's
yeah.
it. You just went off screen of it to the right.
So what are you saying it is?
It's off screen to the right.
Oh. So I had it.
Yes. Those right there.
Yeah, there they are. So this star. Okay. It's eclipsing binary. CO Camel Pardalis. And the other bright one is Hipparchus 9294.
I just thought it was a pretty little group.
Yeah.
Thought it might have a name. Kind of reminded me of the coat hanger asterism. Anyway.
That's neat. Look how it's bright, faint, and bright. It's got a faint central part.
Looks like the tail is slightly bent too.
It does, doesn't it?
The
stars.
lower right half looks like the angle's changed a little bit.
Yeah.
Like the tail has a curve in it or it's broken.
Yeah. Let's see now. Okay.
Little asterism's kind of like a cherry on top.
It is, isn't it?
Pretty cool.
It is. It's very cool. So this is what we're looking at right here. Let's save this. Save it exactly as seen. I would like to move it over to the right to catch the whole dust tail, but it's all right.
To the right, to the left?
Well, to the right, so that the dust tail is visible in its entirety. The anti-tail, as we call it, right?
Oh. I think it's the gas tail.
No. Okay. Let's clear it now and catch the next. It'll be here in 10 seconds. And now. Wow, look at the tail. It does have some really interesting structure. We're going to save that because it's in that first save where it's going to be the most detailed, and it's going to be softened after that. And we need enough exposure to catch the tail.
Tricia, we talked about that earlier. There's some debate whether it's going to return at all. Some people say 50,000 years.
Yeah, but we don't really know at this point, I don't believe. I haven't seen anything but estimates at orbital elements. That's really interesting.
That is a cool little star group down there.
Yeah, it is.
And that tail does look
A little broken up, twisted. Looks like it has voids in here. Remember, it's moving this way, so we could be seeing the next iteration of the same tail. That's the other problem. So, hey, Centaur Flyer, how you doing? This telescope is a 10-inch diameter system. You can see it right there. Kind of small, I agree. And we're using a camera on the front of the telescope, and we're shooting not at f8 like it normally is, but at f2, meaning it's photographically about 25 times faster. So we're seeing things in seconds that might take minutes to capture, or even longer. In fact, I was telling people earlier, this is a MEAD system here, M-E-A-D-E. And for these MEAD telescopes, we have the only one modified to f2 in the entire world. It's the prototype. There'll be more. We're the ones silly enough to take the leap of technology for first time. And as you can see, it's definitely paying off. Okay, we'll save this here. Save exactly as seen. And we have 10 more seconds, so we'll clear and get the next shot. Why am I doing this? I'm doing this because we're taking a 50-second shot of this. And then what we get is this image right there that comes in. We save it right away. And what that gives us is the next image in the motion of the comet. So we're going to actually put them together and make a trail of motion. But then I let it play out and capture a few more just to see some detail down here. And we're at 350 over here, 350 gain, because that's giving us a little more of a punch. That's cool. Okay, we'll save this here. Exactly a scene. There we go. All right, now we're going to come out and do some real-time analysis here. So, okay, there's the comet in real time, and then we're going to bring it down into the field a little more. And move to the east. So move the whole image to the right. Okay. Keep going. Okay. So now what we'll do is we'll zoom in here. So the comet, you'll actually see it moving. And to see it moving, we need to draw some lines. Let me see if this will work.
You could put your reticle on it.
Yeah, I could.
With crosshair.
Yeah.
That'll work.
Yeah, the comet, as we said, the comet is actually moving in this direction. Like that. In our view. Marty Gerlach, thank you for coming. Really good to see you. Thank you for stopping by. You have a good night.
According to the Sky Live, I updated it. The comet is a hair higher than Polaris now. It says 40 degrees, and that's from here in Colorado. And
okay.
Polaris is a little under 39 degrees north where I am.
Okay, mine is 33 north for Polaris. Okay, let's get rid of this arrow here. So just by watching this, you actually can see the comet inching closer to the line. Another way to do this is to actually draw a box. So let me get rid of that shape and let's have the box. So if you draw a box of a certain size, then you can calculate how long it takes the comet to pass through the box. We're not going to do that. And then you can get a good reading of how projected on the sky, how fast it's moving through the sky in terms of arc minutes per minute or arc seconds per minute, arc minutes per hour, whatever you want to do. And so what we're doing is just we have a box. We didn't specify a specific size, but it's kind of cool. It'll allow us to look at some things. Okay, let me let's see if we can Michael Hedrick, you have to go soon. Okay. I know, I mean, hey, look, we had 75 people watching at one point. I'm very pleased. That was excellent. It's not over yet. Wait until the Comet does a real show when it is up near Mars. Oh man, where it's gonna be moving fast too, and we'll be catching that as well. This is a comet made for us, I can tell you that. All right, so let's do one other thing here now. I'm going to I would like to change the exposure, and to do that we'll do this, and we're gonna make it oh, I really want to do more. Okay, we'll do 60 seconds just to see the tail near the nucleus of the comet. That's what I want to see. It's going down this way, so we'll see it. All right, so we have 50 seconds left. Kathy Prinisek, I'm glad. Thank you. Hey, Massive. The focal length is on the telescope right here is actually 520 millimeters, roughly. We're running an f2. It's normally an f8 system, a 10-inch f8, but we're running it at f2, and it's like 530 millimeters actually is the actual focal length of the system at the moment, the calculated focal length. All right. Why did that disappear?
Overexposed?
No, this is up there, and I got to get rid of that. Okay. There it is. And I'm going to back out a little bit. Look at that. So you can see a lot of detail in the tail. That's really pretty.
I just love that little star cluster.
I know, it's pretty cool, huh? It's gonna make a nice photo.
Yep.
Good night, Michael Hedrick. You have a good evening. We'll talk to you again. It is pretty, Maffy. It is. Hey, Marty, I thought you were going to bed. We already said goodnight to you. Can't tear yourself away, huh? It's kind of cool. It's very cool. Tricia says it looks like a magic wand. You're right, Tricia Ferrer, it does. It really does. Okay.
That tail does look different.
It does.
I'm going to have to check tomorrow space weather, other sites that have been keeping current with the comet. They've been noticing changes in the tail and such.
Really?
Maybe they'll mention it if
very cool.
What we're seeing is real.
All right. I'm going to start again here. When something is moving in the field of view against other things that are staying still, in other words, a comet moving against the stars, sometimes that can fool the algorithm, which is designed to match stars to the stars and stack. And we got two stacked, and then the third one wouldn't stack because it couldn't figure out what it was supposed to stack. So we're gonna try and see if we can get more than two now. That's beautiful. Kochab is way down. It's way down like there. It's many fields away. Okay, so we have two stacked now. Look at that beautiful, that dark green, that beautiful green. There's a lot of cyanogen and carbon molecules up there. Mesher 13 is not available right now, Ronald. I'm sorry. Let's give ourselves a little contrast. There we go. Look at that. Marty, I'm already in bed. Okay, all right. All right. Safe flight tomorrow, Marty. What'd you say, Daryl?
More Ronald asked about M13. I just looked. Arcturus and Boötes are just now rising.
Yeah. I told him it wasn't visible, yeah.
Yes. So Hercules ain't up yet.
No. Okay, we'll save this. This is beautiful. That's a beautiful, beautiful comet. Okay. Hey, Eric H. Yes, Eric, if you go here, SkyTourLive.org, and you scroll down one section, it tells you how to get to our free server, and you just click the link and go to our free server, and it's like, wow. You have access to all the photos we took for the last year. in 2 months. Okay, so those photos they're available to you anytime of the day or night. You can just go to the portal skytourlive.org, right, and scroll down. You'll see take me to some cool pictures, and click that link. Off you go. You'll come to our server online, and you'll see these pictures. This picture, when I just saved it a moment ago, it was already shipped off to the cloud, and it's probably already on the server as we speak. So it's going up there right now, so they're available to you. Pushpa Radia, how are you? Thank you for stopping by and saying hi. And guys, make sure you subscribe if you haven't already, because this is, this is just some of what we do. If you were here earlier, you saw the beautiful nebulae we took photographs of. It's just outrageous. Incredible. Alright, now what we'll do is we're going to go back to showing that glittering jewel box at the end of the tail.
Izabella's back.
Hey, Izabela. Oh, yeah, we're still streaming. Absolutely. Did you get some sleep, Izabela? Hello, Lewis. Comments are a good sign, that's right. Yeah. Okay. Okay, you want this.
Pushpa, you might try Stellarium. I'm not the guy to ask for mobile apps because I don't use a mobile.
Oh, I can help you. Stellarium is available for mobile, but if you really want some really cool apps for your phone, if you have an iPhone, get SkyGuide. SkyGuide is outstanding. I don't have any kickbacks from them or anything, but SkyGuide is the one. On Android, I don't know the counterpart, but there's a counterpart as well. But SkyGuide is the best app. You can zoom in and zoom in and zoom in and see nebulae and everything. It's just beautiful. All right, let's see this now. Wow. That's beautiful.
Izabela must be looking at pictures on the server.
She must be.
She noted the little star cluster down at the bottom right.
Yep. And now what we're going to do is go back to our night vision mode. And we're going to go south a little bit. And just a little. And then we're going to go to the west a little bit. I want to bring this cluster in again. There it is. Now I don't want to go too far now because I want to keep the dust tail. Alright. We're going to search for our guide star right here. As soon as it calibrates and initializes, we'll see it guiding and we'll be off and running. There we go. And now we're guiding, so now I can come up here and do a beautiful we'll do a 50-second shot here. Okay, and off it goes. And throw up the stack. And that's what we took before. And now we've moved it up and over, so this cluster will now be in the view a little better. It's really pretty. I already saved this one, but I'm going to save it again. Alright, and now we're 19 seconds away, or 15 seconds away, so we'll clear the stack buffer and get ready for the next one to come in. Alright, Marty, you have a good night.
Ray is here.
Hey, Cosmic Ray, what's going on? Alright, let's adjust this. Do our color.
You notice the tail has walked off that cluster now?
Yeah, I see it. It was in that cluster, and because it's going that way. Yep. Alright. I was waiting for that. Alright, let's add some contrast here.
Izabela, we were talking about that earlier. Actually, I think we talked about it a couple of times tonight.
Well, tell people what she's talking about. Because
can't they calculate when the comet returns by the speed and distance?
Okay. Once we get our final orbital elements for the comet, then yes. Now, if the orbital elements show that it's a periodic comet, then the comet will have a return date that we can calculate. If the orbital elements are open, then in that case, it's not a periodic comet; it's a one-time comet. It might be in a hyperbolic orbit or a parabolic orbit, in which case they will not be coming back, so they're one-time only. I don't know whether this comet is considered periodic or parabolic or hyperbolic. I mean, I don't know.
I swear that tail looks kind of feathery on the end close to that cluster.
It does look feathery.
Like
Yeah.
It's not one stream, it's like several
Well,
segments.
keep in mind that over 2 minutes, which is 2 minutes 30 seconds now, this tail has been moving up this way.
Oh, okay.
So we might be getting an illusion, okay?
I understand.
Which is why I've been taking shorter exposures. The reason I'm doing longer ones now is just to get a beautiful shot, and this is going to be our little pretty shot for the comet. Okay, we'll let this come in one more exposure, and then we're going to save this one. There we go.
Good point.
So now we'll save it and save exactly as seen. Okay. Now, if we really want to know where the comet is, then we're going to do a 10-second shot. Okay. All right. And in a 10-second shot, we'll see right where the nucleus is. We won't see anything else, but we'll see where the nucleus is. And we can track the nucleus. All right, so... Oh, I guess we could see a little tail there, huh? Very little. There it is. We're going to clear this one more time. Okay, we're saving that now. And save exactly as seen.
Ronald, can you rephrase your question? I mean, this is a fork mount.
I know where he's going with this question. With equatorial mount and clock drive, you can track very well compared to just a regular fork mount. He's talking about a German equatorial mount versus a fork mount. Both will track equally well, Ronald. Both have little idiosyncrasies of their own that you have to overcome. but they both do very well, especially these days. That's where he's going with that.
So when he said EQ mount, he's not talking about your mount.
No, he's talking about a German equatorial mount.
Ronald, there are observatory class fork mounts out there that will keep up with any other mount on the market. One is called Mathis Instruments, Mathis, and they are, I think they're still in business. They're really nice, and they're not cheap.
Are they $18,000 mounts?
Something like that, yeah. Let me look real quick.
Look at the way that tail just angles out of that nucleus. That's cool. And the reason I keep clearing it is to get the most accurate rendering.
Yep. Here they are. Want to spend big bucks on a fork mount? There you go.
Well, how much are they? It might be 35,000, 28,000, huh? I seem to recall that number.
Okay, tell me which one I'm looking at.
Wow, what a beautiful comet.
I think not seeing prices anywhere. Must be a case where
if you need to see the price, you can't afford it.
Right. Okay, here are their fork mounts.
Wow.
Payloads of 150, 200, and 320 pounds.
Hey, Ronald, you could put the telescope on these things, and you could ride in the telescope. That's wonderful. Okay. Let's see the actual ping file as recorded. There it is. That's what's going up on the server right now for this last shot we just took. Really pretty. Okay, let's hop out of here now. And again, the comet is moving fast and going out of the field on us. Let's see if there's something else we can look at while we're here. Go over here a little bit, because we should see... There they are. We're going to do a little side trip to these galaxies. You'll like these.
Mark Eric has a question for you. I think you should answer.
All right. Hi, Eric Gage. Let's see. Okay, show some of those pictures on TV too. I have a lot of people haven't been able to see because it's too cloudy. Yeah, you can do that. Just let me know where they're gonna be.
Might want to give credit to him.
Yeah, we'll need the credit, of course. I suppose he would be doing that. I wouldn't expect otherwise. Okay. So this is Measure 81, and we're going to move up north a little bit, and you'll see Measure 82. This is another galaxy in the field as well. Okay. And there's Measure 82. Judy M says 18,500 to 45,000.
Yep.
That's about right. Okay, I was getting some lag, so I had queued up lots of southerly motion or northerly motion. There we go. And we'll take a shot of that and get these two galaxies in all their glory just shortly. One thing I'd like to show you one more time is our patrons. I want to thank our patrons that we have here. Thank you, Mazif. That's very kind of you.
Thank you, Mazif.
That's awesome. That's just beautiful. Okay, we have Ali B, Chief Max Cyber, Vera Lucia Campos, Ronald T, Martin W, and Raymond B. That's our patrons at the moment for our Patreon. If you want to join our Patreon, you can head to SkyTourLive.org and look up to the right. You'll see the Patreon, and up to the left, you'll see this right here. This is our channel on YouTube, and you're able to get there any way you want. You can go to YouTube and search for SkyTour Livestream with Marc Dantonio. You can go to SkyTourLive.org and click on the SkyTour Livestream. You can see about SkyTour Radio, which is a radio show that we do on Sunday nights from 6 p.m. to 8 p.m. on astronomy. We have a good following on the radio and in SkyTour Livestream. So we're actually doing well. This is amazing. And the other thing, too, that's just coming online, and I can't tell you the pricing yet because we don't know it, and I'll just show you real quick. I would like to show you. This is our next set of offerings that we're doing. We're actually going to be offering up products that might be really cool to you to have. And if you don't see your nebula, we can make it. We have heart and soul bags. We have T-shirts and sweatshirts. We have travel mugs. The coolest thing I like the most is this duffel bag. This is a very cool duffel bag. You put it over your shoulder. It's a big bag. We have mouse pads. We have notebooks. We have canvas wrapped wall hangings, framed hangings. We have printed pictures and mugs as well, and on and on. And again, if yours is not listed, and we'll give you, once the store is up and running, we'll tell you all about it. You can go hang out there and see if there's anything you want. But if you don't see the nebula in particular that you're looking for, the object, if we've taken a photograph of it, we'll stick it on there and make the product for you. It's not a problem. It's very cool. But again, go to SkyTourLive.org. That's our portal, and check out SkyTour Livestream up there on the left, and the Patreon on the right, and scroll down to see where to go to find all these images that we take each night, because they're all up there. All right, so let's now let's go ahead and center this up. Go south with it just a little bit more, and then we'll catch our guide star and proceed to take a 55-second photo of this region.
Ronald has a question for you too.
Okay.
I assume the answer will be the same.
On these images on the server, is it okay to share it on my Facebook pages? I think so, Ronald, but let's talk offline about that. You want to make sure you give credit. Yes, you can share it on your Facebook page, of course. But we'll talk about that. Maziv, is this a remote observatory you're streaming from? Yes. That telescope is 2,500 miles from here, out in the desert in Arizona. And I'm in Connecticut on the other side of the country. So for me, it's 1:19 in the morning. For the telescope, it's 11:19 in the evening. Okay. All right, so let's do this now. Let's go into our live stack, clear the last one. That beautiful comet. It's saved on the server. The magic is in getting it to all work, from a long distance. Okay, you're up in Nevada. Excellent. And it's Nevada, not Nevada. Okay, 20 seconds left on this exposure. Izabela's starting her day, and I'm about to end mine, right?
Yep, me too.
Yeah.
Izabela, I used to collect astro pins, I guess you'd say. They're stuck in an old hat. And I don't know where that hat would be. If I could find it, I'd send them to you.
It's on your head.
No, it's not.
You know what a joke is, right?
Yes, I do. Thank you, Eric.
Eric Gage, thank you, man.
There was, I forget what all I had. They're in a hat I wore like 25 years ago.
Okay.
There's Astronomical Society of the Pacific.
Well, those kinds of pins. Okay.
Astronomical League. I forget what all I had. I had a whole front of my hat was peppered with these pins.
International Astronomical Union.
I didn't have one of them.
Oh, you did? Okay.
Astronomical Society of the Pacific had a really cool pin.
Okay. I just want to read it. Eric Gage says, showing love to what you guys do. I'll join more of these streams in the future. Thank you, Eric. And again, thank you for that contribution to both you and to Maziv for contributing. That's amazing. Thank you very much. And we could use it for sure.
And that's quick. Andromeda Galaxy is down, or nearly so. It's about to set in the northwest.
Hi, Nesquik. How you doing? And we do take requests, by the way. We do a lot of that. So if you have any that you'd like to see, like Nesquik asking for Andromeda Galaxy, if it's down, we can't show it to you. But if it's not, we'll check it out. Like we had a request for the Crab Nebula. We went.
Yeah, it is just about to set.
Yeah. So this galaxy here, this is Messier 82. It's known as a starburst galaxy, and the reason you can see, if you look carefully, look at these filaments coming out of it. It's really a strange galaxy. It might be what's called an irregular, because it's really hard to see structure in the orientation it's in now. We'll just get rid of some of the noise here. But inside this galaxy, probably through interactions with this other galaxy down below, which is Messier 81, it's probably been disturbed so much that it ended up undergoing this spate of stellar formation, which is what it's doing. And there's gas shooting out of these central area of this galaxy. Just incredible. Okay. Let's do that. Okay, a little color correction. There we go. So M82 is just a amazing galaxy, as I said. But what this beautiful spiral is also color is just a little bit off right now because we're not with the moon out. It causes some issues with our colors, and we have to adjust them, but it's okay.
Cosmic Ray has a question of you.
Where can one get the DBMS name and schema for the STLS database? Well, when we actually finished putting our database together and getting a front end to it, Ray, we can get you some of that information for sure. I used to develop databases in the past, and the person doing our database right now is Robin Curtis. She's in the chat. If she's still in the chat, she might have gone to bed. If she's still here, she'll make herself known. But she's developing the database as well. So we have to come up with all the ancillary tables. We can do searches now. I can write SQL queries and get responses. I can find out, for instance, every time we've taken a photograph of M81 and at what gain and whatever exposure, we can look up all that data. It's all there for over a year of our data, and she's keeping up with it. So she's adding all the new stuff in as we go, and we're working on trying to work out a way to automate the process so it'll just read the directory, go through and parse the text files that give all the information and auto insert that into the database. It's a big project, but it's really worth doing. So let's add a little enhancement here. We're going to add an unsharp mask to this. Okay, it does tend to artificially brighten the center, but you see more detail out in the spiral arms. There we go. Ray, I see your point, okay, but we're not ready to share all that yet because we're still finishing all that development. We have a rough database right now that we can access with SQL, and we're working on ways to think about the direction for the front end we want to go, which way we're going to go. But I'll keep you posted. I'm not trying to hide anything because it's information that I think is really cool to see. We also have images in there too, so when you get a response, you get a list of all the times we saw M81. You can click on the images and see the subsequent images that we took, which is nice. Yes, Robin Curtis is doing a lot of that database entry.
Are we winding down?
Yes.
All right, because I feel a pumpkin coming on.
That's fine. We're going to do one more look at the comet, and then that'll be it.
Okay.
All right, so I'm going to turn off the unsharp mask here because I wanted to allow us to see the rest in here.
Jesus.
No, Ray, that's not what I'm saying. Okay. That's not at all what I said. I said we're still working on that, and we're going to get that out, and we'll get that to you. But it's not ready to be disseminated yet. I still want to identify this. This looks like a dwarf galaxy to me. All right. Okay, Eric, thank you so much for coming out, man. I really appreciate it. Yeah, make sure you subscribe if you haven't. Okay.
Thanks for your donation, Eric.
Yeah, that was wonderful. So we have actually 3 galaxies in here. We have M81, M82. We have this one. We have another one over here. There's another one up here somewhere. There's galaxies all over the sky. Mazif, we stream pretty much on as many clear nights as we can. So when you subscribe, click the bell, but drop down and hit all notifications. So you'll get stuff for our community tab and actual YouTube notifications that we're going to be going live. Because some people don't actually see the notifications at all. They think it's because they haven't clicked all notifications. Fantasy says when you see pictures like this, it makes you feel how small you are. It makes you realize, yeah, it's true. It's absolutely true.
The third galaxy in the field you have up
Right
is
there.
NGC 3077.
Okay, 3077. Okay. All right, I'll save this even though it's not the best photo, and I'll save it as the M81 and 82. All right, so we'll save it, and then save exactly as seen. When the moon's out, the colors can get messed up on us a little bit, but that's okay. Okay, and then we'll come back here. Okay.
When you get the comet back, I'm going to ask you a question.
All right. I'm going to the comet right now. Here we go. So I'm going to the comet, but it's actually going to be moments away. But we're going to have to go hunting north for it again because the coordinates as given are wrong.
Yeah.
Okay. There we go. So we're going to go up north. And the comet should drop into view just right of center. There it is. Okay. All right. And now we'll go to the west. I could go a little farther south. Thanks, Mazif.
Get her up there in the right hand.
Yeah, left-hand corner, yeah.
top left corner.
Yeah.
Let's see how much tail you can catch.
Okay. Yeah, we have a potential for rain massive out in the desert over the next 2 days, but after that, the comet's actually going to be in prime position and closest to Earth when we'll have our next clear day. So we'll be streaming then. So basically, you're going to get two days off here. Okay, I'm going to now do our exposure here. We're going to do a 30-second shot. And what was your question, Daryl?
Go ahead and
I'm going to go guiding here.
go ahead and shoot a picture first. Let's see the tail.
All right.
That's related to my question.
All right.
There's that little asterism again.
Yep. I brought it in to see where the tail is relative to it.
Yeah. And to see, are you talking about the comet? Is it to the right or left of Cepheus?
And it's going to be to the right of Cepheus.
Yeah.
It's to the right of the North Star. Okay, let's... Here we go. There's the comet tail. Zoom. Looks distinctly blue at this end.
Cepheus is just to the west of the meridian, low on the northern horizon, and the comet is higher up on the east side of the meridian.
Actually, I can show you that if you want to see it. I can show you right now. Okay, here is the live view for our position out there. Here is the comet. Here's the North Star. All right. So if you look at the N2 stars in the Little Dipper, they draw a line almost to it. So this is the time as it is currently out there. This is the location. All right. And that's where we are right now. So there's the North, and there's the comet.
And there's Cepheus.
And Cepheus, that's right down here.
Circumpolar, I guess.
Yeah. Okay. So there you go. And let's go back to our comet image.
Okay, nice.
That's very pretty.
Yep. And the tail is walked farther off the cluster.
Yes, it is.
Okay, I'm going to pose my question.
Okay.
Now then, the gas tail of the comet is pointing directly away from the sun.
Yes.
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 And it's 11:37 p.m. Mountain Time, and at local midnight, the sun is going to be pretty much at the nadir. Okay, the opposite of the zenith. It's going to be below our feet.
Yep.
And therefore, at local midnight, the tail of the comet should be pointing straight up.
You would think so, but you're not taking into account the 3D nature. This tail isn't just going straight to the lower right in a straight line in the same plane. It could be, and is very likely, heading away from us. So we're actually seeing it along the length, but we're only seeing it projected on the 2D sky. It's a 3D object, so it definitely has depth to it. So that's why it looks that way. This end here, in other words, is much, much further away than this end here. It's more heading into the page, kind of a thing. So you're seeing it in 3D. So that's part of the problem. Now the other thing is, it looks like it's looking into the upper right or upper left, but you got to keep in mind the telescope's upside down, it's angled, so that's a little bit different. If we want to see exactly,
yes, telescope orientation and camera orientation.
Yes.
Which I know the camera is angled.
Well, slightly. I mean, it's on the east-west axis, but we're upside down. Okay, so when you look here at this field view, you take a look and you see you've got to turn your head this way to see it right. Okay. And at this angle, the tail is going to be going to the lower left, so this way. Okay. And that's where the sun is, and it's going into the page. So the sun is down there at the nadir, just like you suggested. It makes perfect sense as long as you understand that this is millions of miles further away, potentially, than this part here, depending on the length of the tail, because it's swung around into the page, so it's kind of, you're seeing it projected. You see, this makes perfect sense for where this is. It would be looking directly, it would be pointing directly away from the sun. But you can't draw a line through it and go around the sky and say, hey, well, where's the sun? Because you have to be going, you have to be going kind of on an angle past the Earth, maybe even through the Earth at some point, to actually see where that tail is. If you
align it, it would be a great circle.
Well, yeah, and that's not helpful in this here, because it's not. That's just gonna make a great circle. It's not gonna tell you where the sun is, okay, and where this is pointing. You want to draw this line segment from the back of this through this to the sun, but you need to know how much further away this back end of the tail is out in space compared to the front end. Okay, because based on where it's pointing, to me it looks like it's pointing exactly where it needs to be, as long as this part of the tail is much, much further away, swung further into the page. And then this part here would actually be pointing at us. It's sort of like the illusion of crepuscular rays that look like they're angled out, but in fact they're parallel rays. Okay, but it's an illusion, and that illusion is furthered in this case because we don't know how much further into the page this end goes versus this end of the tail. So it's a three-dimensional spatial orientation issue. You follow?
I hear your words.
Okay. I hear your words.
Let's just leave it at that.
Okay.
Okay. Let's go. I'm turning into a pumpkin.
All right. Okay. Well.
Nice pictures.
Yeah. So that's good. You guys, we will be back on the next clear night, which looks like it's probably going to be a couple of nights from now. So that is probably the best we can do. But it's okay. The comet's going to be higher in the sky, and we're going to be seeing some different features for sure. Anyway. You hear that music, you know it means the end. So hopefully we can entertain you some more. Hope you felt educated, hope you felt enjoyment, and I hope you really liked seeing the comet and all the other astronomical objects tonight. I'm Marc Dantonio. This is Daryl Mason. You're here in the background with us. And we're SkyTour LiveStream. And we hope you'll come back. So have a good night, everybody.
Good night, all.